This is Professor Derek Seitz. Trigonometry unit triangle. The unit triangle is an equilateral triangle with side length of 1 unit, 1 on all 3 sides, as we see here. This diagram bisects one of the angles and has a perpendicular bisector and forming 90 degrees down here, breaking the triangle into 2 smaller triangles. And we know that each angle in an equilateral triangle, all the angles are equal. So 180 divided by 3 is 60. They're all 60 degrees. And if we bisect one, then we get 30. So these little triangles are 30, 60, 90 triangles. Remember, the length of the sides is 1, so the length of this little side here is 1/2, because this is a bisector. Let h equal the height. Using the Pythagorean theorem, h squared plus 1/2 squared equals 1 squared for this little triangle here. That means h squared is 1 minus 1/4, or 3/4. H is the square root of 3/4, which is the square root of 3 over 2. The ratio of the sides of a 30, 60, 90 degree triangle, what we can see then, is 1/2, the square root of 3 over 2, and 1. And remember, when you zoom triangles, the angles stay the same, but the sides change proportionally. So this proportion, this ratio of the sides of a 30, 60, 90 triangle will always remain the same. 1/2, square root of 3 over 2, and 1. If you were to multiply, zoom it by a factor of 2, everything would double, and you'd have 1, square root of 3, and 2. But the ratio is still the same. They're proportional. These are very common angles, 30 degrees and 60 degrees. In terms of radians, we know 90 is pi over 2, and 60 is pi over 3, and 30 is pi over 6. They're very common, and it's good to know these ratios. We will see later that trigonometry involves the ratios of the sides of right triangles. And it's interesting to see from such a simple starting structure, a unit triangle, the mathematical relationships and properties that come out of it.